In this video, we are going to investigate the concepts of absolutely convergent versus conditionally convergent. So at this point in time, given a series, the typical question we've been asked is, does the series converge or diverge? So we've kind of thinking of this as two categories. If we have a series, it should fit into one of these boxes, the divergent box or the convergence box. And what we are going to do now is take this convergence box and we're going to break it down into two categories. There's going to be the category of absolutely convergent and the category of conditionally convergent. And how we are going to define these is we're going to say that a series, A sub n, is called absolutely convergent if the sum of the absolute values converge. So if a series is absolutely convergent, it automatically converges. It's just a type of convergence. If the series itself converges, but the sum of its absolute values diverges, then the series is called conditionally convergent. So given any series, there's three possibilities. The series could be divergent, and then in terms of convergence, it's conditionally or absolute convergence. So let's investigate a very typical example. So is the given series conditionally convergent, absolutely convergent, or divergent? So based upon inspection, we see because of this -1 to the n, we have an alternating series. So let's just go ahead and apply the alternating series test to see if the series converges. So b sub n is 1 over root n, so the limit as n approaches infinity of b sub n, well, 1 divided by something growing arbitrarily large, the limit is 0. Similarly, if we just compare the b sub n plus 1, which is 1 over root n plus 1, and b sub n, which is 1 over root n. Dividing by something bigger, square root n plus 1 versus square root n, gives you something smaller, so decreasing. So what this tells us at this point is that the series converges by the alternating series test. Now, because the series converges, we could have absolute convergence or conditional convergence. If the series happen to have all positive terms, convergence and absolute convergence are the same thing. But with negative terms in there, we have to check for absolute convergence. So check for absolute convergence. So if we take the sum from n equals 1 to infinity, minus 1 to the n, 1 over root n, in absolute value, this would be the sum from n equals 1 to infinity of 1 over root n, which is a p-series, and just to see that more clearly, let's rewrite square root n as n to the 1/2 power. So this is a p-series with p equals 1/2, which is less than or equal to 1. So divergent, which implies not absolutely convergent. So what we've seen with this example, we have a convergent alternating series, and when we checked for absolutely convergent, we found that the series is not absolutely convergent. So what that implies is that the series is conditionally convergent. And oftentimes, for convenience, we will abbreviate conditional convergence with CC, absolute convergence with AC.